So I had a little problem I ran into while doing this video, and I decided I'm going to make a bonus question out of it. Bonus question. Just because it feels and sounds like a very good question for an exam.
Now for the bonus question. So when I started the experiment, I got this battery. It says there it's a 12-volt battery. Just set it back on the side. It says on the side there it's 12 volts, top right, 12-volt battery. But it also says standby use 13.5, 13.8. So before I started with this, I tried my luck and see how this went. So I decided, let's just measure this battery. Ooh, 12.54 volts. So that's a problem. How can I still use this power source and make sure I get 12 volts and not the 12.54 which comes out of this?
So, I have a battery that says 12 volt, but it's not 12 volt. It gives a little bit more, about half a volt more. So in order for me to show you correctly how I measured all these values, I need this power source to give me 12 volts, because we all use 12 volts in our calculations. So there will be a difference between the calculated measure values, but using an incorrect source value will be worse. So how can I reduce the voltage of the battery from a measured 12.5 volts to a usable 12 volts we can use in our calculation? So there are a couple of things you can do. You can use a dedicated voltage limiting circuit, like a voltage regulator or something like that. You can also have like a Zener diode, which you can put in parallel, which forces the voltage to be a certain voltage. But we really this is a little bit outside the scope of this course, so we can add in resistance series, which will use exactly 0.5 volts and leave 12 volts for the rest of the circuit. So resistors in series uses exactly amount of voltage, and then all that voltage adds up to the source voltage. So if we have one resistor that uses exactly 0.5 volts, we will be left with 12 volts over the other circuit. So there's our main circuit. So we have in the main circuit, we have a 100 ohm resistor R1. This parallel branch would be calculated is 176 ohms, and then a 1000 ohm resistor here. But we can add in a resistor right here, right next to the battery, and before R1. You can also have it sort of here. Doesn't really matter, there or there. And now we need to work out the resistance value. So how can we do that? So first of all, we know that it has to have voltage 0.5. So let's use the voltage dividing rule. So there's the voltage dividing rule formula, where Vx is the voltage we want of the resistor, Vs is our source, which is the 12.5, Rx is the resistance value, and that all divided by the total resistance of the circuit, Rx, R1, the resistance parallel, and R6. And just fill in the values. So we want it to be 0.5 volts, our source is 12.5 volts, and the other resistor value is 100, 176, 1000. Go through different math operations, which is all pretty straightforward, and we end up with a value of Rx of 49 ohms.
So we worked out we need a series ohm resistor with our battery, which reduces it by 0.5 volts, and we worked out it's roughly 50 ohms. But the problem is you do not get 50 ohm resistors. Well, you don't get them cheaply. So the closest we have roughly, so how can we solve this problem? We need 50 ohms, we have to use common components. What would be the best solution?
So we could use a variable resistor and adjust its resistance until we have a 12-volt circuit, but that's sometimes a bit fiddly, and variable resistors, well, the ones I'm using, the cheap ones, aren't as accurate. But our second option is we can use two 100 ohm resistors in parallel. And this is then, if you do the power calculation, this is exactly 50 ohms. So why don't we get the correct resistance? It's a manufacturing thing, and you have like a resistor table where you get different resistor values, like 100, 200, 180, 280. There is a little formula if you can calculate which one you want. But if you need a resistor of a definite value, you can do that, just a bit more expensive.
So one solution would be is to use something like this. It's a variable resistor. This one's just one from 0 and 100, and you can twist that knob in the middle until you get the right resistance. But that is a bit fiddly. So what I've done is I've taken 200 ohm resistors and I basically put them in parallel. So if you put two of these resistors in parallel, what does it do? It reduces the ohms to the two parallel 100 ohm resistors gives you 50, and that is exactly what we need and what we will then put in series our battery to drop the voltage.